Hello, wonderful algebra students, and welcome back. This video is going to be a summary of our second lesson in our unit on equations, which is on writing equations to model relationships. Notice this is part one. We're going to be doing part two tomorrow. And as a reminder, this video isn't the entire lesson, but it is a shorter video to help you summarize all of the great stuff that we hope you learned in that lesson and really help you cement in the learning goals for that lesson. Which, speaking of, our lesson goals for this particular lesson, there are two of them. The first is really understanding the use of variables in these mathematical models that we started talking about yesterday. And then the second goal is writing equations to describe relationships and constraints. With the writing equations part, if you had me for pre-algebra, you know we did a lot of that in pre-algebra, and we're going to be doing a lot of it in this lesson, in this unit, and honestly, throughout math, right? Especially in algebra, a big part of it is being able to represent situations and relationships with equations. So to jump right in, the first part of our lesson was talking about the use of variables. So to help us with that conversation, we're going to be talking about this situation here. The situation is, suppose your class is planning a trip to the museum. The cost of admission is $7 per person, and the cost of renting a bus for the day is $180. There's two questions I want you to think about in a moment. The first question is, how much would 24 students and 3 teachers cost? And then the second one is, how much would 30 students and 4 teachers cost? I encourage you to go ahead, pause the video now, and try to tackle those two questions on your own. All right. So the important information in this situation here that's going to help us calculate these two things is that we know it costs $7 per person. And we know that you're going to have to pay for a bus, and that bus is $180. Now notice up here it's using that language $7 per person. So when I get to the question 24 students and 3 teachers, there's not separate costs for students and teachers. Everyone is a person. So you could think of it as those 24 students would each cost $7. So I would need to multiply 24 by 7 to find the total cost of the students. And those 3 teachers would also cost $7 each. You can think of it that way to get the total cost of the students and the teachers, or a different way to think of it is to figure out how many people you have in total and multiply that by the cost. So I know it costs $7, and I would want to multiply that $7 by how many total people there are. So there's 24 students and 3 teachers. So thinking of it instead as like 7 times 24 plus 3, or 7 times 27. Either way you think of it, there's still one other step there. We have to add in that $180. So for each of these, after I figure out the total cost of admission for the students and the teachers, I would need to add in my $180 for the bus, and I would need to add in my $180 for the bus. As I'm working through this, I'm really paying attention to the math I'm doing because that's going to help us in a little bit. Either of these expressions, when you go to do that multiplication, 24 times 7 is going to be 168, plus 3 times 7, that's 21, plus 180. All of that would add up to give us $369. If you had been using this one down here to calculate instead, I'm thinking of it as 7 times 24 plus 3. That's 7 times 27 plus our 180. Well, I know 7 times 27 is 189 plus that 180. And when you add those up, guess what it's going to give you? It's still going to give us that 369. For the other question, we can tackle this one similar to the first one. I'm going to use the second one if that's okay. So I would want to multiply my cost per person, that $7, by how many total people are going. Well, there's 30 students and 4 teachers. That means that total cost of admission would end up being I'll put it down here. 7 times 34, and 7 times 34 is going to give us 238. And then just like before, I'm going to have to add in my bus, that $180 for the bus. And so when I add in my $180 for the bus, whoops, that's not 190. When we add in $180 for the bus, that gets us to a total of $418. Now, the real purpose of this lesson isn't to do calculations like these, but remember our topic is being able to use variables. And a big part of variables is paying attention to which numbers in these situations, which quantities can vary or change. Both times, the cost of admission, that $7, that was a constant value. So was the bus here, the cost of renting a bus for the day. Both of my calculations here have $7 and 180 in them. What did vary, and I'll scroll down a little bit, what did vary were the number of students and teachers. How many people are going on that trip? That's definitely something that could change. When it comes to using variables, we can use variables, which are these letters we've been using, for anything that varies or changes in situations. So 2 questions I want us to think through next. We'll start with this first one here, is based on this situation, what variables might we use to help us represent the situation? In a moment, we're going to come up with an equation. My equation is going to have some variables in them. What might those variables be? Pause the video and try that now. Well, my variables are going to be the 2 things that we said are varying or changing in this. Those 2 things are going to be the number of students and the number of teachers going. So I might use S to represent the number of students, and I might use T to represent the number of teachers going on the trip. And you can make it even more specific by saying the number of students going on the trip and the number of teachers going on the trip. Notice for my variables, when I'm defining them like this, I'm not just saying S as students. We want these definitions to be as specific as possible. The last question for this is, what equation then could we write to help us represent this situation and that total cost we've been calculating? I've got these 2 variables now. How could I put them all together in an equation? Again, go ahead, pause the video, try this on your own. I scrolled it up a little bit in case you needed that information up here. It's going to be a combination of using this information and our variables to help us come up with that equation. And if you're stuck, you can always use these calculations here that we had done earlier to help you figure out the equation. Notice both times what I needed to do was I needed to multiply that 7 by the number of students and the number of teachers. We might write that as 2 separate calculations, 7 times the number of students plus 7 times the number of teachers. Or we could write that calculation using those parentheses we had mentioned earlier, where we were finding the total number of people going. So I could write it like this, or I could say 7 times the total number of people, and the total number of people would be the number of students plus the number of teachers. So either of these would be a good start. The other thing I had to do every single time was that bus, right? Each time I was adding in that $180 for the bus. So I would want to include that as well. I would say $7 for each student plus $7 for each teacher plus $180 for my bus. Now notice my bus here, that number doesn't have a variable with it. If I come back to my calculations, I was never multiplying that 180 by anything. It was just that like fixed price of the bus. So that 180, that number would be by itself. We don't need a variable showing I'm multiplying it by something. If your equation looks like the second one here, it would also have that plus 180 in it. Now, there's one word I want to point out in this question. That's the word equation. Neither of these things I have down here is an equation yet, because we know equations need equal signs. So I might come in and say equals, it needs to equal something. Well, when I was doing these calculations, it was me figuring out that total price, that total cost for the trip. I can't use T for total because I'm already using the letter T for teachers. So I might say equals P. And I'm going to add that to my list of variables. What do you think P is going to represent? We said it a moment ago, it's going to be that total price. When we're thinking about what's varying in this situation, the total price is also varying. It's going to change depending on how many people are going. So both of these I'll end with a equals P. Now, in your equation, you might use different letters for your variables. That's totally okay. The key here is that mathematical relationship happening between our numbers and our variables. You might use X and Y for students and teachers, but I still should be able to find we're multiplying the students and teachers by 7. Now, we were saying variables are great things to use when you're working with quantities that can vary or change. Some quantities in your situations might be fixed or constant. So, for example, we had mentioned earlier that bus rental costs $180 no matter what. It does not matter. It doesn't change depending on how many students or teachers are going. And this is assuming that we're only going to need one bus. We're only going to be renting one bus that day. We might also choose to use variables even if something is constant. And the reason we might do this is there's 2 parts. We might want to do this if we don't know what the value is. So let's say you know it's going to cost $7 for each person going on this field trip, and you know you're going to need a bus, but maybe you don't know what that bus is, the price of that bus is yet. We might use a variable in that situation. Or we might want to use a variable to really understand that relationship between the quantities. And what I mean by that is up here, notice we were always adding the price of that bus. I might use a variable there if I really just want to focus on this idea that I'm going to have to add in the cost of the bus. I'm not subtracting the cost of the bus. I'm not dividing the cost of the bus. If we really want to focus in on that addition, using that variable there helps us take away the distraction of the 180 and focus on that math. So to practice with this, I've got 2 questions that I want us to think through. For example, what would our equation look like if we didn't know the cost of the bus rental? And what would our equation look like if we didn't know the cost of admission for each person? What I'm going to do is I'm going to copy this equation down here just to help us with this next part. And as always, I encourage you, pause the video, try tackling these 2 questions on your own first to see where you're at, and then come back to get that answer. For the first one, my equation would look really similar to this, even if I didn't know what the cost of the bus rental is. I do know that it's costing $7 per person, so I would still have 7 times the number of students and the number of teachers together. The difference here is if I don't know what the cost of the bus rental is, I wouldn't have 180 in my equation. I do know there would be addition there. So I'm still going to put that plus sign because I know I would have to add in the cost of my bus. But if I don't know what 180, if I don't know that 180 price, if I don't know how much it costs, I could just use another variable. So maybe I want to use B, and I would have to tell you that B is going to represent the cost of renting a bus. Similarly, down here, we've got what would our equation look like if we didn't know the cost of admission for each person? Again, the math or the operations in this equation are still going to be the same. I would still be multiplying the price of a ticket times how many people are going. The difference is I wouldn't have the cost $7 in my equation. Instead, I might say, let's use C, I guess, for the cost of admission. I would want to multiply C times the number of students and teachers. Or if you were thinking of that other equation we had earlier, the cost of a ticket times the number of students plus the cost of a ticket times the number of teachers going. Here, we could still use that B from earlier as well. So I could say I'm multiplying the cost of a ticket times the total number of students and teachers going plus the cost of my bus rental to get that total price of the field trip. Now, looking at these equations might look crazy to you because there's only variables in them. There's no more numbers. But looking at these equations really helps us figure out that mathematical relationship between these quantities. I've got a lot of addition here because I'm adding up all these different costs to figure out that total price. This first part of our lesson really focused on this idea here of using variables. You can use variables definitely when quantities are varying or changing, but you might even choose to use them with fixed values here, which results in equations that might look like this, where there's a lot of variables in them. The other focus of our lesson was being able to write equations to represent situations like these. And again, this is something that we worked on in this lesson, but it's something we're going to continue to work on throughout this unit. To help us with the second part here, we've got this question about a school choir. This is also what a lot of the homework questions look like, where we're given this verbal description and the question is asking us to represent it by writing an equation. This was the cool down question from the lesson. So if you were in class for the lesson, this is going to look really familiar. You probably already did it. But if not, I strongly encourage you again, pause this video, try this one on your own, and then come back to check and see where you're at. And you're back. So this question about the school choir tells us a school choir needs to make t-shirts for its 75 members and has set aside some money in their budget to pay for them. The members of the choir decide to order from a printing company that charges $3 per shirt plus a $50 fee for each color to be printed on the shirts. We had mentioned already the goal of our first part is to write an equation. We want to write an equation that represents the relationship between the number of t-shirts ordered, the number of colors on the shirts, and the total cost of the order. And then, as always, if you use a variable, specify what it represents. When I go to write an equation, I'm going to come back again and read through this story one more time and highlight any of that important information. So our first sentence is telling us a school choir needs to make t-shirts for its 75 members and has set aside some money in the budget to pay for them. So I know there's 75 members and they need t-shirts for the 75 members. So they're going to need 75 t-shirts for the choir. Okay. The next sentence says the members of the choir decided to order from a printing company that charges $3 per shirt plus a $50 fee for each color to be printed on the shirts. So far I know they need 75 shirts, and then it's giving me some prices. It's giving me $3 per shirt plus, look at that word right there. I know my equation is going to have a plus sign in it, plus a $50 fee for each color to be printed on the shirts. My problem here, number one, is telling me to write an equation, and we want our equation to describe the relationship between all of these things and figuring out like that total cost of the order. So if I'm going through this, I know there's 75 shirts we're going to need, and it's $3 for each shirt. So if I'm trying to find that total cost, I would need to multiply the 75 shirts I want times the cost of each shirt. And it's telling me right here, each shirt costs $3. So for that total cost, it's going to have that 75 times 3 in it. 75 shirts times $3 per shirt. It also says plus, so I'm going to put that, plus you're spending money on something else. You're spending $50 for each color on the shirt. Now, did it tell me anywhere how many colors they're using? I don't see that. So that's something that could change. It could vary depending on what that shirt looks like. So all signs point to that's a variable I need. I'm going to use the letter C to represent the number of colors on the shirt. So in my equation, I'm going to say they're spending $3 on the 75 shirts plus $50 times how many colors they choose to use, $50 for each color. And together, that total is going to give me the total cost of the order. I'm going to use another variable there. T is going to represent our total cost of the order. So I end up with this equation here. You might have already done that math too, the 75 times 3. 75 times 3 is going to be 225. So you could have also written 225 plus 50C, equals T. The second question is getting at what we had started at the beginning of this video talking about with what can vary. In this situation, which quantities do you think can vary and which might be fixed? Well, for what's going to vary, I already know these things are going to vary because I had to use variables for them. So the quantities that might vary are the number of colors on the shirt, the total cost of the order, but there's also something else here that might vary. Do you know what that something else is? The other thing that might vary is the number of shirts you're purchasing. Maybe before you go to place this order, someone joins the choir. That number of shirts then is something that could change. So we've got the total cost of the order and the number of shirts ordered. For things that might be fixed, I'm going to say fixed quantities. Quantities are those prices there. Those prices are prices that have been set by the company. Those aren't going to change. So I'm going to say fixed quantities are the price per shirt and the fee. The fee for each color. We could write an equation just like we did with this last one here, where we used variables for everything. But in this situation, because we've got that information there, I'll go ahead and use it in our actual equation. This is the end of our summary video. I hope you found this helpful. Make sure you come back for part 2 tomorrow, where we're going to talk more about writing equations to model these relationships. Thanks. Bye.